Hi, folks. Today, we are going to discuss soldering irons for fine electronics that support 0.4mm and thinner soldering tips with internal heating. They're usually quite expensive, because they are often only sold with soldering stations. I used to have a relatively inexpensive Ersa Multi-Pro 20-watt soldering iron that operated on 230 volts AC grid voltage. However, recently its heating element has broken and I've also learned that the soldering iron had been discontinued. I could have only bought a new heating element and I could have repaired the soldering iron myself, but the heating element had also been sold out and I would have to wait for weeks to get it. Ersa had been selling so-called soldering tools for their analog and digital soldering stations, which were basically simple soldering irons with special power connectors that could have only been used with soldering stations. At first, the idea to build my own soldering station seemed a bit scary, because of a variety of connectors Ersa have used to connect them to the soldering stations. Fortunately, I was able to find Ersa's soldering tools connectors pinouts on the internet. Soldering tools for Ersa analog soldering stations only have a standard 3-pin connector that had been commonly used to interconnect analog hi-fi audio devices in the 80 ties. Pins 1 and 3 are connected to the heating element and pin 2 is connected to the casing. You may also connect pin 2 to the ground, if needed. The soldering tool operating voltage ranges from 0 volts to 24 volts AC at maximum effective power of 60 watts. Ersa's soldering stations have an inbuilt AC voltage regulator controlled by a potentiometer with a button and a scale with an estimated soldering tip temperature for each setting. But there is no sensor to measure the soldering tip temperature and no temperature regulator. If you want a soldering tool with a temperature sensor, you should buy one for a digital soldering station with a connector with 4 pins on wall. A soldering tool with a 4-pin connector has 2 pins to power the heating element and the other 2 pins to connect its internal temperature sensor to a temperature control circuit in the soldering station. However, I had decided to go for the cheapest option and I bought a soldering tool for an analog soldering station. I've also powered it with an industrial 12 volts DC power supply with a maximum current of 15 amperes. This way the soldering tool would have also worked with a car battery or a computer uninterrupted power supply battery, which is good to know if you are going to repair your car or work in places with no access to the electric grid. How it works. I've measured electric current to have made absolutely sure not to damage the new soldering tool. At first I've measured an electric current of about 3.6 amperes, which was about 42 watts at 12 volts DC. As the soldering tool heated up, the current quickly dropped below 2 amperes to prevent soldering tip heating above the maximum of 350 degrees Celsius. DC current is about 1.41 times more efficient than AC current at the same absolute maximum voltage of plus or minus 12 volts. AC current soldering tool power would only be 30 watts. This configuration is perfect for soldering fine electronics with a 0.4mm soldering tip, and there is also no danger of being electrocuted if you mount the soldering tool power supply line with a soldering tip by an accident. Thank you for watching. Click like and subscribe buttons if you liked the video. You can find more projects like this on Cusp Projects website.